We're going to create a password here with 2 letters followed by 5 digits. So we're still going to use the idea of the fundamental counting principle. We're going to draw spaces for each decision that we have to make. So we have to make 7 decisions here when creating this password. And the thing that we're also going to do in this one is whenever you're using the fundamental counting principle, they want you to communicate a little bit what each of your decisions stand for. And it doesn't have to be like an essay. In fact, in this case, all that I would expect is I have 2 letters followed by 5 digits. So I think it's enough if I put L for letter and D for digit. That would communicate what's going into each of those decisions. So each of the spaces represents a decision. Underneath that decision is a little explanation what that decision was about. And then the numbers that go into the spaces represent how many choices you have. How many choices of letters do you have? We had an argument here. There's 2 letters in the alphabet, correct? No, there's more than 2 letters. Wait a minute. 24 letters? How many letters in the alphabet? 26. Whew! Get me nervous. I know, that's the scariest part for math teachers, this part of the unit when it's like an English question. How many letters in the alphabet? No, there's 26. So we had an argument in the other class. Should we write 26 or should we write 52? Because you have smaller case or uppercase, right? Now this question was expecting 26. So they didn't make a difference between lowercase a and uppercase A. And then you are allowed to repeat. It says you're allowed to repeat your digits more than once or letters more than once. So you'd have 26 again. What about digits? 10. Why is it 10? Because we include 0. And we don't worry about lowercase 3s and uppercase 3s.
It's still important.
What? Yeah? Yeah, like uppercase 3s, those are like exponents, right? Maybe. And it would be 10 for each of these. And you multiply them all together. And you get just over 67 million passwords. Now this would not be considered that strong of a password. But there's still 67 million different ones that you'd have to check. Okay, questions you can do for this one are 5, 7, 8, 9, 10, and 16. And I put a star beside 16, so it must be really hard.
It's a fun one.
The star means it's a fun one?